Hi, I'm David Kais. I'm here to talk to you about how to make 1,000 plots look good, data viz for parameterized reporting. If you're interested in following along, I've got a QR code as well as a link here that you can use to access the slides. I'll leave that up and I'll tell you just a bit about myself. So I founded 5.5 years ago R for the Rest of Us. R for the Rest of Us does education work where we teach people to use R, and we do consulting work where people hire us to do the R for them. A lot of our consulting work involves making parameterized reports. This is an example of a report that we've worked on for the last several years. It's called Oregon by the Numbers. We make all the data viz for this report for all 36 counties in Oregon. It's some ungodly number of pieces of data viz, maps, charts, etc. If you're not familiar, by the way, with parameterized reporting is the idea of kind of making one template document and then using that to iterate and making multiple reports. We did this exact thing when working with folks in Connecticut. We have made housing data profiles for each town in the state of Connecticut. There are 169 towns, a lot of towns. And we make both the data viz as well as the report. We do the report layout in either our Markdown or Quarto. Here's what that looks like. We worked recently with folks at Johns Hopkins University, the International Vaccine Access Center. They were partnering with the World Health Organization on what's called Immunization Agenda 2030. This is a project looking at vaccine access with some goals set for 2030, and we created reports to help various countries kind of track their progress. We're currently working with some folks at Portland State. It's called the Child Welfare Partnership. They do trainings across the state for child welfare workers, think like social workers, people who work in foster care, that type of thing. And they do surveys kind of pre the trainings, post the trainings, and we help them to produce those reports. And you can see what those look like. So I'm not actually giving a talk today about report design in R, although I am giving a talk on that topic at PositConf in August. So if you're interested, please do come to that. I'm also not talking about parameterized reporting. I know JD Ryan did a workshop yesterday on that topic. Super interesting. Definitely talk to JD or myself about that if you're interested. What I am talking about is data viz tips when you're making parameterized reports. The first thing I want to tell you is that there's really no magic package. Ultimately, there are packages that can help you, but it really comes down to you thinking deeply about your data. What you need to do, first of all, the first kind of category of tips that I'm going to offer is you need to consider the outer limits of your data. So, for example, here's a chart where we look at population by race ethnicity in every county in Oregon. The data that we work with looks more or less like this. You've got county, population, percent, and percent formatted, which we use for the text labels. We make a function that looks like this. You can see we have race ethnicity that's piped into a filter where we filter for whatever county we want to plot, and then that gets piped into ggplot. When we run race ethnicity bar chart for Multnomah County, it looks like this. I'm only showing the text for the white group, the largest group, for reasons that will become obvious in just a minute. And if I run this for Baker County, a county in eastern Oregon, it looks like this. Now, the odd thing about this is that the largest bar for Multnomah County, 68.1%, is the same length as the bar for Baker County. And the reason why is because our function just makes the largest bar equal to whatever the largest group is. Now, the way I've dealt with this is I have actually added an additional bar that goes all the way to 100% to ensure that the value or the size of the green bars is consistent. It's a little bit subtle, but around each bar, there is a dotted light green line. And I do that by adding an additional geom call, but I set my aesthetic properties differently. I say x equals 1, in other words, go up to 100%. I set the fill of this bar to be transparent, the color to be that which is a light green, and then make it dotted. So when I run this for Multnomah County, you can see we get that on the outside. And then also for Baker, we get that. And you can see that now the largest bar, that white bar, goes up to the value or the size that you would expect it to. We ran into a similar issue making median household income charts comparing each county to Oregon. And so here's what the data looks like. You've got geography, amount, and amount formatted. And again, very similar process where we create a function that we then use in each report. So I take my median income data and I filter to keep the county that we want to plot as well as Oregon. And then again, pipe that into ggplot. I'm only showing a section of the ggplot code because the details are less important than the overall process. Then if I run median income plot where county to plot equals Jackson, we end up with that. Looks fine. If I run the same thing for Harney County, it looks like that. But if I run this for Washington County, it does not look right, right? Look at Oregon. For the first two, the bars are the same size. But for the last one, where Washington County has a higher median household income than Oregon, it's not the right size, or it's not the same size as the other two, which looks weird. So to do this, what I need to do is I need to calculate the max median income for any county. So I do that by starting with median income. Then I use the slice max function. And I say for the amount variable, keep only one. So keep, in other words, the top value for amount. Then I pull amount. And I save that as the variable max median income. Then what I do is I use this. So I set my scale x continuous. I set the limits in scale x continuous to go from 0 to max median income. So in other words, they go from 0 to whatever the max median income for any county is. So if I run this for Jackson, it looks like that. And see how it's not actually going all the way to the edge? Same thing for Harney, and same thing for Washington. And everything lines up in that Oregon bar, which is going to look much better than if it's inconsistent throughout. The next kind of category of tips that I want to offer is to minimize text and position it really carefully. The thing when making data viz and parameterized reports is that your text is going to overlap. And so you really need to think proactively about how to avoid this. First thing is I want you to try not to label everything. It's really tempting to think you need to do this, but really think deeply about what does the reader need to focus on and just label those things. As an example, here's a chart that we made looking at population projections in various age groups for every town in the state of Connecticut. Here you can see it for Hartford. The data that we use for this looks more or less like this. You got location, year, age group, percent formatted. And my plot I make with a very similar function where, again, I'm filtering. In this case, I'm filtering for the town that I want to plot as well as the county that I want to plot and Connecticut because I'm showing all three. Then I pipe that into ggplot. So if I run population projection plot for Hartford and Hartford County, we end up with this. Haven't added any text yet. I'll do that next. To add text, the first thing you might think to do is do geom text where AES label equals percent formatted. If we do that, it's going to add text on every single point and line. It just kind of looks messy, right? So one solution I see people reach for is to use a package called ggRepel. It's a great package. It enables your text to repel from each other so that the text doesn't overlap. And so you might think to try that. That looks better, but it still looks kind of messy, right? Like it's just so much text. It's hard to read. So again, don't try to label everything. What we have done in this case is we said, well, really, what's the most important? Well, let's highlight the town that the report is for. So we do that by adding a geom text, but we filter our population projection data for that town, in this case, Hartford. Then we use nudge y to put the label just above the Hartford line. So when we do that, you can see it looks like that. If I do the same thing for Stamford, another town in Connecticut, it looks pretty good. The only issue, though, is you can see a few of the text labels here, like in the 5 to 19 group, 40 to 64, and 65 plus. They're right on top of the lines, and it makes them a little bit hard to read. One solution that we have used for this is to use the shadow text package. Shadow text just adds a little bit of a shadow around your text and makes it a lot easier to read. So with shadow text, you basically do the same thing. You use geom shadow text, but you can add BG color. So in this case, I'm doing BG color of white, which you can see just adds a little white border and makes it a lot easier to read. If you look at the 65 plus, for example, you can really see that. The next tip on working with text is to hide small values. So here is a chart that we have made for housing cost burden for renters. Housing cost burden is basically how much of people's income do they spend on their housing. The data looks like this: location, burden level, percent formatted. And again, very similar process. Take our data, we filter it to the town and county we want, as well as Connecticut, pipe that into ggplot. When I run housing cost burden plot for Hartford and Hartford County, we get a stacked bar like that. The issue, though, is that if you look at that not computed on the right, those text labels are kind of pushing on the edges of the bar, and it just looks a little bit messy. So to deal with this, let's look back at our Hartford data. It looks like this. What I have typically done in this situation is I've said, okay, well, if the value is below a certain threshold, let's not even show it. And I do that in this way. Take a look at line 3, where I say percent formatted equals if else. If percent is greater than 0.07, then keep percent formatted. But if it's not, then make it NA. So when I run this now, you can see my housing cost burden data looks like this. And take a look at line 4 for not computed, where it has percent formatted, which is missing, which is exactly what we want, because if we run the same code again, we get no text on that not computed section, which looks much cleaner. I could do the same thing for Stamford, which is in Fairfield County, and again, it looks good. Last text tip is to not put text where it could be obscured. This is a sample data viz that we made looking at kind of pre-post knowledge ratings for the reports that we're working on with folks at Portland State. And so you can see what we've got there. So we've got our pre-post data, which looks more or less like this. And we have the question, the timing, rating, growth, which is like basically the difference between the pre and the post. Growth formatted, which we use to put the text value, and then growth text position, which we calculate like right in between the pre and the post. We've got a function pre-post plot, which we take our data and then pipe it into ggplot, and then have the geom line as well as geom point. So when I run this, you can see what we end up with. We don't actually get any text. So to get text, the first thing we do is we add a geom text where we add the rating within the points. So label equals rating and color equals white, because we're just going to make all of them white. The pre-post labels, so in other words, like put those right above the bars. The growth labels, so geom text for that, where we set the label to be equal to, however much the growth was. And so there you can see it's 2.6. That works very well in this case when the data looks like this. But what happens when our data looks like this, where the growth only goes from 3.5 to 3.6, not as big, right? In that case, it's going to look really messy. So we need to deal with this. What we've done is we've decided, instead of putting things right on the bars, put them on either side. So if it's pre, let's put it to the left. If it's post, let's put it to the right. And I know this works because we took a look at the data, and there's never a case where there's like negative growth. So we're going to calculate a variable, rating text position, which is equal to, if timing is pre, then make it rating minus 0.2. In other words, move it to the left. If it's post, make it rating plus 0.2. In other words, move it to the right. So you can take a look at what the data looks like after we run this. Now, when we do our geom text for rating text position, we're just going to put, or for the rating, we're just going to put the X aesthetic as rating text position, not as rating. And we're also going to put our timing label there, we'll put it at that rating text position. So now you can see it's on either side of the dots, which is great. But you see how that growth is still kind of in the middle, still looks messy. So to do that, what we ended up doing was actually putting it all the way to the right. We did that with a geom label where we said x equals 6. In other words, put it all the way to the right where we know it will never be overlapped by any data. The last kind of set of tips that I want to offer is I want to tell you to highlight strategically and programmatically. What I mean by that is I want you to think about various ways that you can highlight for example, the country that you're showing in that particular report, and do that within your code. I want you to consider using a range of aesthetic properties, so things like color, size, shadow, outline, and opacity. For color, what you can do is an example from again, going back to our Connecticut reports. This is a chart looking at single-family homes as a percent of all homes. Each of the gray lines represents one town in the state of Connecticut. And that big blue line represents the town that's highlighted in that particular report, in this case, Hartford. The data that we use for this looks like this, just have location and then percent. And we make a function for single-family homes plot where we pipe our single-family homes data in. Then we use geom_point. The one line that I've highlighted is line 10 here, where I have shape 124. The reason I do that is because shape 124 actually makes those straight lines. You might not have seen that because you might be confused thinking, wait, that's geom_point, that should be a circle. That's how we end up with those lines. What we do then is we add a layer on top of this with geom_point where we filter our data so we only show Hartford. And we use the color, in this case, that's a dark blue, to have Hartford show up differently than the other towns. Now, it's still a little bit subtle, right? Like you can see it's all the way to the left, but it might not be totally obvious. So one way we've made this more obvious is to use size. So with size, what we've done is we've said for the Hartford point, make size equal to 15. And that makes it a lot more obvious. You can do the same thing for Stamford, and that's obvious as well. It works for any town. The last thing I want to talk about is using shadow. So shadow is something that we have used in this report working on the Immunization Agenda 2030 reports. So here, for example, is a map looking at the status of rubella in various countries. This is taken from the Afghanistan report, where the goals have actually not been achieved. The data that we're working with here is actually geospatial data, which explains the kind of metadata at the top, as well as the geometry column on the right. The data, the other parts of the data, you've got country, region, and status. What we do is we plot this, we make a function called region map. And we use geom_sf to plot our geospatial data, where we say data equals rubella, but we filter for region 1, and there we say fill equals status for our aesthetic property. What that does is for each status, it makes it a different color. We have this region equals 0, and we make that light gray. Those are all the kind of surrounding countries. And so when we run region map, you can see what we end up with. Now, if we wanted to highlight Afghanistan, one way that we do this is using shadow. We use a package called ggfx, and we use the function with_shadow. Wrapped around the geom_sf, just focusing on Afghanistan, what that does is it gives a little bit of shadow for that country. And you can use this with bars, you can use this with anything you want. But you can see how it makes Afghanistan pop just a little bit. Now, it's still a little bit subtle, so we use an additional aesthetic property, outline. For that, I added align width 0.8 and color equals white. And you can see how now Afghanistan is even more apparent. One last tip that we have used to make it even more apparent than it has been up to this point is to use opacity. And opacity we actually use on the background layers. So all the countries kind of that are colored, but not the country we're focusing on in that particular region. And for that, I said alpha equals 0.75. And what that does is it makes all those countries kind of fade a little bit into the background, but because we have an additional layer for Afghanistan, it pops off of the screen and is just really easy to read. You could do the same thing for a rock and it would work as well. So, in conclusion, first thing I want you to do is consider the outer limits of your data, minimize your text and position it really carefully, highlight strategically and programmatically using a range of aesthetic properties. And finally, when making data viz and parameterized reporting, packages are helpers, but really it's up to you to do the thinking. Thank you.